Awesome. Are we going? We streaming?
We're streaming. Making
Okay.
posts.
Go ahead. Oh yeah, I'm host now. Awesome. Good morning, everyone, or afternoon or evening, depending on where you are in the world. Today we're going to be going through an MLFlow and Featureform workshop. It's going to be pretty hands-on. If you want to follow along, there is a repo on GitHub. It's github.com/featureform slash featureform dash MLFlow dash workshop. If you're in Zoom, it's in the chat. If you're anywhere else, if you go to the Featureform GitHub, the organization, it's the newest repo. It just got made. Like I just published it a few minutes before this workshop. So we'll be working out of that. So I'll give a few minutes for people to get cloned if they're going to, if they're going to follow along. Otherwise, I'm going to start sharing and talking through what we're going to go through today. So where did my Chrome go? Oh, there it is. Okay. So I'm going to share my screen. I'm going to talk about what's in the repo, and I'm going to talk about what we're going to do today. So in terms of what's in the repo, there's only a few things that are relevant. One is the definitions.py, the setup.shell, and featureform-mlflow.ipy notebook. So setup.shell is what sets up everything. We'll run it first. It just runs all of our Docker containers. So it deploys Featureform, it deploys MLFlow, and it deploys Postgres and Redis, which we're going to use with Featureform. There's definitions.py, which will configure Postgres and Redis with Featureform. And then finally, there is the IPy notebook. That's where we'll spend most of our time today. It is the notebook that we'll run through to build our training set, to actually train a model, and then finally to kind of deploy that model in production and then serve features to it. So that's the setup today. I'm going to take a moment and just talk about what we're doing and why. So I'm going to first talk about the simplest model, like when we think of what a model is. A model is this thing that takes inputs, which are called features, and makes a prediction. When training, we'll also compare our prediction to a label, which is kind of like the correct answer, and then we will adjust our model's weights accordingly. So that's the different components of a simple model. In reality, data science is so iterative. We'll end up with tons of notebooks, tons of models, tons of different features that we try and use and throw away. And it's chaos to manage all these things. The most painful parts of it are managing experiments, managing models, and managing data pipelines. So Featureform is all about the management and orchestration of the feature pipelines, the data pipelines. And then MLFlow is about orchestrating and managing the experiments, which are kind of like training runs, and the models, which are artifacts like trained models. So together, you can manage your model lifecycle more or less from end to end. So in ML, there's kind of 4 stages of the ML lifecycle. There's the data set and the data piece, which I spoke about. There's model experimentation and training, which again, like it's just after you create some training sets, you're going to play around with models and train models and run experiments. Finally, you'll deploy, and when it's deployed, you'll want to monitor and evaluate. So we have, and I'm not going to go through it today, but we have this kind of whole breakdown of an ML platform from the data over to the monitoring and evaluation. We have different layers of this, and we talk about it. Now, for the sake of today, we're going to be deploying Featureform. And then here I say Spark and Redis, but actually we'll be doing Postgres and Redis. And that's going to manage the data piece of the ML lifecycle. And then for the experimentation piece and the model training and model storage, we'll use MLFlow. We'll work in a notebook, and then I have Kubernetes down here, but actually we'll just use Docker Compose, which will just make life easier when getting Kubernetes set up. So these are all the components that we will deploy today to kind of have V1 MLOps platform. So Featureform is used for feature orchestration and management. It runs on top of engines, services, data services that actually do the storage and transformations. So Featureform acts like a configuration layer, a metadata layer, and an orchestration layer. Whereas the actual data transformations and storage happen in this example in Redis and Postgres. MLFlow is about experiment orchestration and management. It keeps track of all the experiments you run, all the training runs, and it stores and manages all your models. And then the training service, in this case, we're just going to do it locally on the Jupyter Notebook. The goals of an experiment tracker of like MLFlow is to centralize experiment logging, have reproducibility on your training, collaborate and share, and then model versioning and management. For a feature store, the values of a feature store is facilitating deployment, enhancing collaboration, organizing experimentation, increasing reliability, and preserving compliance of the feature pipelines, which is like the data pipelines. So facilitating deployment is like getting your features from your notebook into production much simpler. That is complicated due to streaming and batch and on demand and like all the complexities that come with actual production. The other value of a feature store is enhancing collaboration and organizing experimentation. You maybe have been asked like, hey, what is this feature? Or you've looked at a training set and been confused at what this thing is, how it was created. So this is a common problem. Featureform automatically solves it for you. So that, even if your features are in production, rather than digging through untitled notebooks, crazy table names, ad hoc Spark submits, and no feature documentation, Featureform kind of sets all this up for you. It's a framework to define, manage, and deploy your feature pipelines. A little out of scope today, we also have feature monitoring, we have governance and compliance rules, but we're not really going to get into that today because we're focused on a much more simpler use case. Awesome. The only other piece that I want to maybe share before I get to code is the Featureform, how it works, where it sits. The Featureform framework sits between your infrastructure, whatever the infrastructure is. We call ourselves a virtual feature store because we support a wide variety of infrastructure. And then what you're doing is you're providing the Featureform framework with your specific business logic. So your SQL queries, your PySpark transformations, etc. You define these things via the Featureform framework. And then Featureform will manage those things, store them, run them for you, and orchestrate your infrastructure, your engines. So that's how it all comes together. I think, I guess maybe one more thing just before I get into code. So when people hear feature store, they imagine a database where features are stored, which tracks, right? I mean, it's in the name, feature store. And there are some feature stores that look like this. We call them literal feature stores, where you run your transformations elsewhere, and then you store the final result in your literal feature store. This is how SageMaker works, how Databricks works, how Feast works. The problem here is that in our definition, the features are the transformations, they're deeply tied together. Because if you change the transformation, you kind of want the features to update as well. You don't really want those to be two separate processes where you're updating transformations, then recreating new feature tables, writing to new feature tables, pointing models to new feature tables. Rather, what you'd like is something where the transformations and the feature store are kind of tied together. This is an approach of a physical feature stores. There's many companies doing this, a lot of vendors that do this. The problem with the companies that do this today, like Tecton, is that they have their own transformation engine. So you can't use your own Spark or your own Postgres or your own ClickHouse or whatever, or your own Redis. Like you're kind of moving and replatforming your data on a feature store, which can be very expensive. It's high adoption costs and it's prone to failure. Featureform is what we call a virtual feature store, where it provides that same abstraction of data scientists are defining their features as PySpark and SQL transformations in Python. They have a dashboard where they can view things, monitor things. They can use those features for inference and training. They get a resource repository, search and discovery, monitoring, governance. And then the difference here is that Featureform is actually just orchestrating your infrastructure. So it doesn't have its own transformation engine or its own storage engine. Rather, you kind of plug those things in. Awesome. Let's get to code. So, let me switch. Actually, I'm going to switch back here, but I'm going to do this a little differently. So I'm going to share Chrome again. I'm going to talk about, well, actually, I'm going to share my terminal. So if you're following along, you should have git cloned that repository, which is, again, Featureform dash MLFlow dash workshop. Once you do this, you can go into your terminal, which I'll share mine in a moment. So I'll share my terminal. Okay. So you see my terminal. If I ls, you can see once that goes away, or I'll just do it again, that this is the same repository that we get cloned, the one that's in GitHub. The first thing we're going to do is call setup.shell or run setup.shell, /setup.shell. This is going to run our Docker containers for Featureform, Postgres, Redis, and MLFlow. So we'll do that. So mine happened super fast because I've already run this before and I've already have all these things installed. For you, it might take a bit longer. Now, as I'm letting you all catch up for those following along, I'm going to show you what we've done. So if I do Docker ls or Docker, actually, I'll just show you the Docker UI. Because I think that will just be easier for people to follow along with when trying to read my small terminal script. So if I show you this, you can see that I have a few things running. Now, I ran our ClickHouse quick start as well, but we're just going to be working with Postgres and Redis today. So I have Postgres running, Redis running. I have our ports rather connected to my host port. I'm running Featureform. There's 2 ports here. This 7878 is for the API, and this 80 is for the dashboard. And then finally, I'm running MLFlow. With MLFlow, I am pointed at port 8000 for my UI. So let's go take a look at those UIs now. So I have all these things running. I can show you the Featureform UI and the MLFlow UI. So going back to Chrome, so I'll share that. Okay, so first let's go to Featureform. So if I do localhost 80, you can see the Featureform UI. Now, there's not much in here, right? It's empty. And that's because I haven't created anything yet. But once I create things, they'll be in here and they'll be searchable. Now, similarly, if I do localhost :8000 or wherever you run MLFlow, you can see MLFlow. And MLFlow, again, no runs, no models, nothing, because I haven't done anything yet. It's all empty. So let's start creating things. So first thing we're going to do is in our terminal, we're going to create and configure our Postgres. So the way we're going to do that is if I go, there's a file called definitions.py. It registers Postgres. It registers Redis. And then it registers a table that is in Redis that we create as part of our quick start called transactions. It gives that table a variant. A variant is like a version. And the variant here is raw. So I'm going to apply this file. And the way I'm going to apply it is I'm going to write Featureform, apply, definitions.py. I'm going to set the host to localhost 7878, which is, again, where my API server is running. And then I will also set this flag insecure. The reason you have to set the insecure flag is by default with our quick start, we don't set up HTTPS because we don't set up SSL just to make life easier. But Featureform by default assumes things are secure. If they are not secure, what's the word? Yeah, it assumes it's secure. And then if you want it to be insecure, you can just set that flag. So let's apply this. So you can see it happens super fast, but it created two providers, Postgres Quick Start and Redis Quick Start, and a source variant, which is like a data set, which is transactions, and the variant or the version is raw. Providers don't have versions, which is why there's nothing here. There's no error. All the statuses are ready, so we look all good. If we want to verify, we can do, so I'm actually just going to export Featureform host equals localhost 7878. The reason I do this is so I don't have to keep saying the host parameter. But I can now do things like Featureform list, providers, insecure. And you can see, I can see my Postgres Quick Start and Redis Quick Start as my providers. And if I list my sources, I can do the same. I can even do Featureform get source, raw default, insecure. And then source variant not found. Raw, oh, the transactions raw. And you can see that it would give me more information about that specific transaction. There's not really much here because I defined it with very minimal information. Awesome. If I also want to see in the UI what I've done, I can do that as well. And I can do that by going back to my Featureform dashboard. And if I go back to localhost 80, here I'm just doing a new tab, so I don't have to keep switching back and forth. Localhost 80. You can see my Featureform dashboard. Again, there's no training sets, but there are now two providers, Postgres and Redis. If I go to Postgres, I can actually see that there are sources in Postgres. If I click that source, I can preview and I can see information about that source. Or when I preview, I see the data in the source. Great. Now, most of the time when we're working with Featureform, we won't be working out of our dashboard. We won't be working out of Docker and doing stuff with Docker. That's just all more or less set up. So typically, like a typical data scientist using Featureform, this will all be set up for them when Featureform is created. And most of what they'll be doing, most of what you'll be doing is actually working out of a notebook. So let's switch to the notebook. So here's my notebook. I'm going to make the text bigger so it's easier to follow. Okay. First thing I'm going to do, if it's relevant, is just install and upgrade my Featureform library. So PyPy library, MLFlow, and scikit-learn. Scikit-learn is where we'll train the model. MLFlow is, again, the experiment tracker, and Featureform is the feature store. So we'll get all this set up. I'm already upgraded, so nothing happens. First thing we're going to do is create a client to Featureform. When we use Featureform in our with the Python file, we were using the CLI. Now, when we're working in code, it's typically easier to just create a client directly in Python and use that. So we'll create a client. Again, we point at localhost 7878 and secure set to true because with the Docker container, we don't have SSL set up. So we'll do that. Very simple. Nothing happens. Okay. Now we talked again about how we have Postgres, Redis, and this dataset transactions are all defined in Featureform. Now we want to build off of those things. We want to build transformations for them. We want to build features. We want to build training sets. We want to do all that stuff. Now we need to retrieve the resources from Featureform to be able to build off of them. And it's very simple to do. You just have ff.get. So we have get Postgres, get Redis, and get source. So we'll call this, and that will get all three of these things. Very simple. All the data resources like this can be also transformed. Like this object is like a Featureform object, which isn't that useful potentially for you if you want to do some like look into the data, understand what the data is. But if you use client.dataframe, you can turn any of these objects into a data frame. You can also set a limit if you don't want to, because it's going to kind of download that data to your local laptop or computer. And maybe you don't want to download 1,000,000 rows. So you can just limit to 1,000. And that gets it as a data frame. Now, this is a Pandas data frame, but we also support Spark data frames, especially if you're using Spark as a provider. So yeah, this is our data frame. Okay, so obviously we're gonna want to build features off of the raw data. When we work with something like out of like a perfect Kaggle data set, sometimes we don't have to do any feature transformations because it just works by default. But in reality, we often have to do transformations to build better features, get better signal from our data. So let's create our first transformation. Now we're working out of Postgres, so we're going to use a SQL transformation. But Featureform does support both SQL transformations and data frame transformations. For SQL transformations, we create a function. We decorate it with, this is Featureform specific. We set Postgres, which again is that thing we retrieved from Featureform here, from that get Postgres. So we're saying, hey, this is going to run on Postgres. It's a SQL transformation, not a data frame transformation, which we also support, though not in Postgres. And then here, you could specify your variants. You could do, there's a lot of metadata that can be set here. But minimally here, we just set inputs, which is a list. And this list can be the name variants, or we can just use the object, the Featureform object, which in this case, we're going to use transactions. So this transactions data resource gets mapped to this parameter table, and we work off of that. This is a PyDoc, and it becomes a description of this new data set. And then this is the actual logic. So we return a SQL query, which is a string. Get all of the columns and include another column called balance %, which is transaction amount divided by customer account balance. Now we have to be careful to not divide by 0. So if we are dividing by 0, we just set it to be 0. Yeah. And that's it. And then, we do from, and then this is the Featureform specific piece of the SQL query, which we use the mustache syntax, and we include the name of the parameter we want to include. So in this case, from table. Do client.dataframe. Again, everything, including this transformation, can be converted to a data frame. So we take the name of the function and convert it to a data frame, and we run this. So this is actually, it ran super fast, but it ran on Postgres. It created a new table in Postgres. And then Featureform retrieved 1,000 rows from that table into a data frame. In Featureform now, if we go to sources, we can see this new source % balance. Now I'm really zoomed in, which is why it looks kind of weird. But yeah, you can see the code that was used to define it. You can see the description that we set. We can see the provider was Postgres. We can go through the lineage. We can see any training sets, features, or labels that depend on the source. As of now, none. And then we can obviously preview it to see the data in it, which includes that new column, balance percent. Okay, let's go back. So we can get way more complicated. Here's a window transformations where we're doing a rolling mean of the transaction amount over the last 30 rows for the user. So we partition by customer ID, we order by timestamp, and then we do a windowed function. Everything else was more or less the same. This is just a more complicated query. And if we run this, same thing, starts as no status, and then we switch to pending, and then goes to ready. It's almost instantaneous. It's because this query is still running pretty fast. But yeah, now we can see we have these new columns, rolling mean and rolling count. This is useful to do this kind of, there's a lot of windowed functions and features because you want to not just know what the value of the feature is now. If you have a feature that's changing values over time, you want to be able to know what the feature's value was at different points in time. This allows you to be able to train correctly because when you train, you're training on historical data, which means you need to be able to calculate the features as they would have appeared historically. So you need a log of the feature values, not just the current feature value. And now we can define our features. Create an entity. An entity is like a primary key. So we associate features and labels of entities. So in this case, we're associating the feature, these three features, and a label with the class user. User is an entity. We set the Featureform data set, which is transactions, window ag, or percent balance, which are all the things we created. We specify the columns. So optionally, there are two, which is the primary key and the value. And then potentially a third one, which is, in this case, the timestamp. We specify the type. We can optionally specify a variant, which is, again, like a version. If we don't, it just auto-generates one for us. Everything in Featureform is immutable, but it doesn't feel immutable because we just generate variants if you don't set them. And then you can also, for features, set an inference store. So rolling mean, right, it has a timestamp, and when we're training, we want to be able to get the features at different times. In production, we only want the most recent value of these features. So we want to materialize the most recent value of these features into Redis for online serving. And when we set the inference store to Redis, Featureform does that for you. It will create your training set, which we define down here. Training set's name fraud, variant basic, label features. And then then it will materialize the features, the most recent values of the features into the inference store. So let's run this. Boom, run, creates. Again, this needs to take a little bit longer. So we see this pending. And then it will eventually generate the training set. Like I said, everything's immutable. So one thing that's interesting is like if I wanted to, for example, change this to variant simple and I would have to do that if I want to change anything, like if I want to change this variant or something. So if I run this again, you can see that it created the things that already existed, right? Already exist. But for the new thing, it creates a new one. So this is where immutability is really nice. If you have feature pipelines that already exist, Featureform will use them. So it won't recreate things. But it won't allow you to overwrite them. If you want to overwrite them, you have to change the variant. Or if you just don't set a variant, it will automatically generate one for you using a timestamp like this. So now we built a training set. Very simple. We can look at those training sets in the UI. Like we have this fraud training set. We can look at the features that are part of it. We can look at the, or this is one of them. There's the other one, which is simple. See it's ready. We can see the label attached to it is fraud. We can look at the source of that, which is that original data set, which we can look at. Like we can get all of the information from here. Cool. Now we can train our model. So to train the model, we're going to set up a few parameters. One is the model name, which we just generate. Create the training set name and variant, fraud, simple. A random state, so we can regenerate that model. And the test size, which is like, so we can create a train test split. We generate the Featureform URL using the training set name and variant. We're going to associate this with the MLFlow experiment. So in the MLFlow experiment, you can actually link to Featureform and see the training set that you created. We'll get our training set. We'll specify this optional model parameter, which is just a string. And that allows us to tie the MLFlow name to the Featureform name. So we can jump. The goal of this is to connect MLFlow and Featureform. They both work like separately, right? Like now we're past the data part. So we're to the training part. So this is kind of the MLFlow domain. What we're doing here is we're creating the connections between MLFlow and Featureform such that we can jump back and forth between them. If we want to see what the experiments that are using a training set, we can do that, and vice versa. We can actually see which how the training set was generated for a given experiment. So we set up MLFlow. Again, we ran MLFlow on localhost 8000. So we'll set that. We'll create a train test split on our data. And then we will start a run. So with MLFlow, we do with MLFlow to start run. This creates a new run, which we'll see soon. We're going to use a random forest classifier, which I'm importing from scikit-learn. I fit it on my X train, Y train. I create my accuracy score by predicting the X test. I'm printing the accuracy. And then with MLFlow, I'm logging all my parameters. I'm logging a metric, which is accuracy, and I'm logging my model. I'm also, and you can do this in the MLFlow UI, but here I'm doing it manually or in the code. I'm also registering that model. So logging it creates like an artifact as part of an experiment, but you can kind of upgrade it to like a first-class model by using the register model API call. So let's do this. Let's go through this again. We're creating a training set. We're specifying the model name that we're going to be using with this training set. We're setting up our test train split. We're starting an MLFlow run. We're fitting a random forest classifier. And then we're logging all the relevant parameters for that run, including the model. And then we're actually upgrading the model into the model store in MLFlow. So let's run this. Take a moment. This is our training set. So this is from Featureform. So you can see the first two columns with the kind of generated names are the features. The final column is the label, which also comes from Featureform. We get this accuracy score, which isn't great, but it's also not like exactly a state-of-the-art model. In MLFlow, oh, it's still running. It's still training. But once this trains, which again, it'll take like a minute, we'll be able to see, we can even see part of it now. If we go back to MLFlow, we can see this train. So I'm gonna make this like a little bit not so tiny. You can see that I have these parameters. One of the parameters is the Featureform URL, which I set, I actually set it wrong. I said it's internal sandbox, which it shouldn't be that. But if I copy this here and I set this to localhost instead, which I should have done, you can see that, hey, here's my training set. Here's the features in that training set. I can go into them. I can see what they were. I can look at the stats if I had the metrics. We don't support metrics for Postgres, but you could see the training sets that it's associated with. You can go to the source and you can see that code, that complicated windowed query that we created. In MLflow, and then finally, you can also go to the model itself and you can see what training sets this model was trained on. So you can kind of go back and forth between MLflow and Featureform. Okay. Oh, and then the last thing in MLflow, which I want to show, is that I also have this model version 1 is stored in the registered models. So now I've trained the model. That train run I have logged, so I can recreate it. I have the features and feature pipelines and training sets I created to train that model. And finally, I have everything going. So now, obviously, once you train a model, if the model had great accuracy, like this one doesn't, but if it did, you might want to deploy it to production. And so we support batch serving features. But let's say you want to serve it in an interactive way, like a recommender system where you make API calls against it. Let's get that set up. So the way we're going to do that is in two parts. One piece is we're going to create an on-demand feature. On-demand feature is like a Python function that runs at the time of the feature request. Why we need this is sometimes we have parameters, like we have balance %. So we need to divide the transaction amount by the balance. The issue is that I won't know the transaction amount until request time. So it's a parameter. And so I would need to set that parameter here. For entities, in this case, like the user ID, which I'll use to grab relevant features. And here what I'm doing is I am getting two features, average transaction and on-demand %, which I should create real quick. I am, so you can see I created the on-demand feature. Sorry, a little slow right now. So I get those two features. I have the parameter and I have the entity. I'm going to print those features. I'm going to grab my model from MLFlow. You can load it as like a function, a Py function. And then I can use that model to predict the label for the set of features. In this case, just a single feature. So if I run this downloaded the model. It retrieved these two features. So the average transaction, or the average transaction for users C5124051 is 500. The balance % for this specific thing with 1,000 transaction amount was about 1%. And then, if I see a $500 transaction, it's 1% of my balance. This model decided that this is not fraud. And so I grabbed the model, I gave it those features, I had it predict, and it predicted not fraud, false. The other thing I can do here, which I should mention, is I can set the model equals, and then what did I call the model? Model name. If I run this again, should give me the, again, it will download again. It will give me the same prediction in this case. But I can actually go back to my feature form. I can go to my models and I can see which features I served in production, like the average transaction and on-demand %. So again, I'm tying my models to my features and vice versa. So now all of my training runs, I can see how I trained, but I can also dig into the training set itself. What is this training set? How is it created? Where is it? Can I retrieve it as a data frame? Can I retrieve different parts of it as a data frame, or different like intermediaries as a data frame? At serving time, I can see which features are being served to this model and how those features are defined. I can even look at like basic distributions of those features. I can look at the lineage of that feature. So it really adds that management layer and that framework to define, manage, and deploy features and also to manage and orchestrate your experiments and your model store. Now, in an actual MLOps like platform, like a true like end-to-end platform, this would only be about half. The pieces missing, one is actual deployment. Like here, we're not really deploying the model. I'm just retrieving it like a Python function. But in the real world, I'd want to deploy that model somewhere scalable so that I can make requests to it. And then if a model is in production, I want to have some form of evaluation framework to be able to monitor those things and see how the model is doing in production. We'll have following webinars where I will give examples of those things and build more end-to-end platforms, MLOps platforms. But here, what we really did is we focused on the first two pieces, data and feature engineering and model experimentation and training. These are the offline parts of machine learning. And I think those are probably some of the more core problems to be solved in MLOps is around that. So that's all I have for you today. We're a bit ahead of time. If you have any questions, if you're on LinkedIn or Twitter, you can just throw them there and we'll answer them. If you're in Zoom, you can just ask in the Q&A and I'll answer them. And I'll give a few minutes to do that while people are maybe writing or thinking of a question. Marie, I'm going to hand it to you so you can kind of do any final housekeeping and send off. So Marie will send you all an email after this. In that email, she will include links to our next webinar. She will also, this is recorded, so we'll send a YouTube link of this thing. It will also include a link to our Slack community. Our Slack community is a great thing to join to just keep up with what Featureform is doing, be able to ask questions. We have a lot of people in there, hundreds of MLOps practitioners you can ask questions to. It's a great place to just kind of be on top of things. So she'll send that after. It'll also include a feedback form, which we'd really appreciate. We'd really appreciate your feedback on how we're doing, what you thought of the webinar, what you would change, what you wouldn't change. Otherwise, that's all I have. If there's any questions, I don't see any on Zoom. I'll check the LinkedIn view real quick and see if there's anyone there who asked any questions. I don't see any. So yeah, Maria, I'll hand it off to you to end the webinar.
Awesome. Thank you, Simba. And yeah, thanks again, guys, for attending this workshop. As Simba mentioned, I am going to send all of you a follow-up email with the recording, as well as links to our docs, Slack community, and also a form if you have any questions, you can fill it out there. Yeah, have a great rest of your day, everyone.